Okay, this is my Chapter 18 reassessment. And the first problem is, what is the equivalent resistance between points A and B if R equals 1.0 ohms? The second problem is, if a 20-volt EMF is connected to the terminals A and B, what is the current in the 2.0 ohm resistor? First things first, we drew our little picture from the book. Okay. And then we found the resultant resistance, which is R1. So R1 is equal to R plus 1.0 ohms, which is right here. And then we do R equals 1.0 plus 1.0 equals 2.0 ohms. And then we come down and we write 1 divided by R2 is equal to R divided by R1. 1 divided by R1 plus 1 divided by 2.0 ohms. And that's going to give us 2.0 divided by 2.0 ohms. So we end up rearranging all that to solve for the R2, and R2 is equal to 2.0 ohms. The next thing we do is we find the equivalent resistance between points A and B. Okay, and then we're going to do the R equivalent is equal to R2 plus 4.0 ohms, and then we're going to substitute 1.0 in for that, and it's going to be 5.0 ohms. Okay, and then for part B, we finally use the V equals I times R equation, and we're going to rearrange that to be I equals V divided by R equivalents. And the R equivalents up here is the number that we got down here, so we bring that up and we plug that in right there, and then so it's going to be I equals 20 volts divided by 5.0 ohms, which is going to give us 4 amps. And then our loop rule, we do EMF minus I2 times 2.0 ohms minus I times 4.0 ohms equals 0. And then we're finally going to substitute all our little numbers in that we found. So like the EMF, we sub that in, and the I, we sub that in. And we're looking for I2 in this. So eventually we're going to get to down here, and it's going to be I2 is equal to 4 volts divided by 2.0 ohms, and it's going to give us 2 amps. So that current is 2.